Okay, it's 11 o'clock. Let's get started here. So today we will do a final exam review. No class again on Thursday. Wednesday of next week is our final exam at 10 a.m. to 12 p.m. here in this room. So since we last met, I've handed back the projects. Were there any questions about the projects? Okay, before we get into the final exam review then, there's two things I want to mention. First of all, just an application of where regression analysis can be used. Have any of you heard of Kaggle Competitions? Okay, this is a data analysis a company that called Kaggle that hosts data analysis competitions where you can actually win money by having the best model. And as they say on their website, we're making data science a sport. Anyway, so I sometimes get word of some of these competitions that come about. And one particular competition that's being hosted by Kaggle is this one that General Electric wants to do that involves basically, let me get to the first page of it, which involves trying to improve the commercial airline industry in terms of predicting arrival times of airplanes. And so Kaggle's hosting the actual competition that GE is proposed, and anybody can actually sign up to participate in the competition, either individual or groups of individuals. And what they are trying to predict, go here to evaluation, what they are trying to predict, they have two response variables: runway arrival time for an airplane and gate arrival time for an airplane. And so what they've done is actually they made available a data set of I think about 2 weeks worth of actual airplane arrivals this November all across the United States. And using this data set, they're asking people to come up with a model to try to predict airline arrival given a number of predictor variables. And look how they're going to evaluate then who has the best model. Something very similar to what we've seen before, what they call root mean square error, square root of essentially a mean square error, where they're taking 1 over the sample size times the sum from y equal 1 to n of y sub I, which could be, for example, gate arrival time, minus y hat sub I, the actual predicted gate arrival time given by the model. And then they square it. So that's how they evaluate the actual different models using a tool that we're used to seeing. And this is a timeline of the actual competition. So November 29th, what they did is they made available an initial training set, data set that people could use. So this is like our model building data set that we learned about in section 9.6. Then on December 18th, those who have submitted particular models, these models will then be tried out on what they call a test data set, which is just like our validation data set in section 9.6. And then based upon that, they will provide an initial leaderboard about who has the best model. And then there's a few other parts of the competition as well to finally get to a point of who wins the competition. And, it pays to be able to come up with a good model. They're going to pay $100,000 for the best model. And this is, I don't know if those prize numbers are always, those prize dollar values are always used, but throughout Kaggle, these are competitions where you can make money. And people actually do this for a living. They'll enter these competitions. Let's see. And lastly, they are using regression models, but usually more sophisticated regression models than what we talk about in this class. Again, in this class is kind of a gateway to more sophisticated regression models that you can learn about in our other STAT courses. So anyway, an interesting example of how regression analysis is used and how you can make money off of it. Second, before we actually get into then the review for the final, I wanted to let you know that I have posted all of your grades on the Blackboard website for this course. You shouldn't check it right now, but after today, or I'm sorry, after our course, after our class today, please check your grades just to make sure that I have entered in everything correctly, because of course there's always a chance for error. I always want to give you the opportunity to double check your grades with mine. And right now what's posted there is information about your projects in that day number 1 quiz. So for example, maybe project number 5 on this, or project number 3 on this example here, 41 out of 42 points were earned. Also, I have information about your test grades. So then using what I stated on the syllabus, then you can come up with an overall project's grade by simply taking the number of points earned divided by the total number of points possible. Your overall test grade is then just an average of the 2 test grades. And then your current grade for the course right now is factored the following way. Take your overall project's grade times 0.3, because remember 30% of your grade is the overall project's grade, plus the test grade times 0.5, because 50% of your grade are these tests. Take that all divided by 0.8, because we only have 80% of the total grade so far actually completed. Then you get a current grade before the final. So all this stuff is given to you on the Blackboard website. Now, after finals are graded, I will also post your final exam grade. And let's say it was 89. Then your overall course grade, 0.3 times the project grade, 0.5 times the test grade, times 0.2 times the final exam grade. This ends up being 91.65 for this particular example, which would translate into an A-. So just an example of, again, how, at least what's laid out in the syllabus, how these grades are calculated. Are there any questions about that? Okay. Is there any questions about anything else before we start a review for the final? Okay, let's review for the final exam then. Okay. So, if you have any last-minute questions about the final exam, I will have virtual office hours in the chat room available from the course website. It will be Tuesday, December 11th from 9 to 10 p.m. The exam's the same kind of format as what we've seen before. It is comprehensive. It includes material before and after our last test. The general layout for the exam is 100 points possible. Problems number 1 and number 2 and number 3, just three problems. Number 1 and number 2 are some kind of data analysis where you're going to need to use R. I'm going to give you some data, similar to what you've seen before in terms of the style. And number 3 is a combination of short answer questions that are not necessarily connected in any way. So usually on my test, the very last problem is these kinds of questions. So again, similar to what we've seen before. On the test web page, there is a formula in our help handout. I will give that to you during the exam, but of course you should take a look at it before the exam just to make sure you know what's going to be given to you. Now again, after after the final exams have been graded, I will post all that. I will post your grades then to the Blackboard website. I will then put a message on the listserv saying, okay, grades are done. You can go take a look at them. If you want to see your final exam, please come stop by my office. I do recommend that you make an appointment. Since it's finals week, I'm in and out of the office a lot, especially this finals week because my department is interviewing for a new department chair, actually starting Thursday of this week, but we have people coming in next week as well, so I'm going to be out of my office a lot dealing with interviewing stuff of these candidates. So I do recommend making an appointment and you can take a look at your final exam. Also note, I forgot to mention this at the beginning, I will not have office hours next on this Thursday coming up because of this interviewing that we're doing for our department chair position. Okay, so that's the general structure then of the exam. Let's review some material. So chapters 1 through 9, if I were to do a review of that material, it would basically be exactly what I said before. Of course, all of our classes are recorded, so you can always go back and view the corresponding video of our past reviews. I do recommend that you do that. But then for chapter 10, the first thing that we started off talking about was added variable plots. The purpose of these added variable plots is so that you can get a better idea of what the correct form that X should be in the model given other variables are already in the model. And so the way that you do that then is to do a little scatter plot of your, and let's consider a case with two predictor variables. Let's say we want to do a plot for X1. What you do is you plot the residuals for a model that has Y as the response, X2 only as a predictor variable. You plot that versus the residuals from a model that has X1 as a response and X2 as a predictor variable. And essentially what you're trying to do is you're trying to adjust out the effect of X2 from both Y and X1 so that you can look at Y and X1 given X2 is already going to be included in the model. No. X1 given X2. This is a plot for X1. If you see like a kind of a linear pattern in this plot that says, okay, you have a linear relationship. So after you adjust out X2, you have a linear relationship left over. If you have like a kind of a curve, like quadratic pattern that says then you have a quadratic relationship, and so on. So make sure you can construct these plots on your own. Remember we have the AV plots function, but also make sure that you can actually describe how to do one of these plots and why we are actually plotting these elements there. Then we talked about outliers. Spell outliers, unfortunately. And we focused on now studentized residuals and studentized deleted residuals. Make sure you understand how to calculate them, obviously, using the appropriate R functions, but also how to interpret them in terms of how can I determine if something is potentially an outlier. Again, that's where the t distribution comes in. We also talked about Bonferroni adjustments to this t distribution value that we look at in order to make a judgment about is something potentially an outlier. But also remember that if you're using, let's say, alpha point, let's say 0.01, let's do 0.05, it's easier to describe. Let's say if you're using alpha 0.05 within this t-distribution, let's say you have 100 observations. Then you would expect on average about 5 to be outside these border lines that you get from this t-distribution. It would not be unusual to have that happen. And as long as they're not extremely, extremely far from the border lines, then that's reasonable. Nothing to worry about. We also talked about hat matrix diagonal values. Make sure you know how to calculate them or how to get them in R. There was some really, really good plots, I think, regarding the high school and college GPA data set where we added a 21st observation to the data set that really helped show you what these hat matrix diagonal values are actually measuring. So I recommend that you take another look at those. Then this led into our discussion of influential observations. Why are they bad? Well, if it's influential, that means that your model could change whether or not an observation is in the data set or not, and thus potentially changing your conclusion about the effect of, let's say, an explanatory variable on your response. And we don't want that to happen. So we looked at 3 different ways to look at these influential observations. DF fits, Cook's distance, and DF betas. Make sure you know how to calculate these, what they represent. For example, why is Cook's distance, let's say, a more serious problem than a problem maybe detected by DF fits. Make sure you understand how to detect the problem cases. If you remember, we had certain guidelines that we would use. A short answer question I had given before on a final exam is something like, well, compare and contrast these 3 different measures. Because, you know, all 3 are looking at little bit different things in how one evaluates influence. So compare and contrast these 3 different methods. We also talked about something called the VIF, the variance inflation factor. This is used to help detect multicollinearity. Make sure you understand why this is a better measure to look at than simply, let's say, a scatter plot or a correlation matrix to show that only 2 variables are have a potential multicollinearity problem. Well, the VIF allows you to look at cases where maybe multiple variables, their linear combination, are strongly related with 1 variable. And if that's the case, then we want to detect when this happens. And the VIF helps you do that. Make sure you understand how to calculate it and why we are using this particular formula to calculate it. If you remember, it relies on a coefficient of determination, or R squared. Then we completed with the NBA GUARD data set, we completed the model building process. I recommend that you look that over again. You'll understand how we found potential problems with the model and how we found solutions, and also how there was maybe more than 1 solution that would be justifiable. A problem that I've given on a test before is simply run my, if you remember my, can't spell it again, examine dot mod dot multiple dot final dot R, I guess, program in the corresponding function that's in there. Run this function that's in there, and now go through the whole model evaluation process. There's like 5 different things that we look for. Actually go through all 5, where I would, let's say, assign points to the correct interpretation or correct evaluation of all 5 parts that we would look at. Then I might say, well, what would you do next? So given all this stuff that you've told me, what would you do next with this model? Is the model okay to use, Or do you need to do some kind of fixes to the model? Then we spent a little bit of time going back to Chapter 9, in particular Section 9.6, when we talked about model validation. Why would someone want to validate your model? Well, you're looking to make sure that you got this great model here, but you want to make sure that it's going to work in other cases other than for the actual data that you had collected. So we looked at a variety of different ways that one could validate one's model. We said, well, one could use a holdout data set, which essentially means you're splitting your data into a model building and a validation data set, or also called training versus test data. And make sure you understand the advantages and disadvantages of doing that. Or one could go out and collect new data. Of course, there's advantages and disadvantages to doing that as well. Once we have a validation data set itself, this is when we can calculate particular items such as the mean square prediction error, MSPR. We could re-estimate the betas. We could look at semi-studentized residuals as well. So we can do these kinds of things to evaluate our model. Make sure you can actually make these calculations. You know how to interpret then the end calculations as well. That takes us to Chapter 11. So we've talked about the various assumptions of our mathematical model that we have. And we've talked about, well, what happens if I have a particular violation of the model? How do I handle it? We talked about, simple solutions. Sometimes those solutions are just not going to work out. So the purpose of Chapter 11 was to at least get you started thinking about these other ways that we can go about handling problems with our model. And these all rely on some quite big deviations from the model that we talked about from Chapter 1 through 10. In particular, we talked about weighted least squares. And this gives us another way that we can estimate our model, where we assign weights essentially to every observation. Ideally, this is used in cases where you have non-constant error variance. And the weights that we assign to every observation depends upon these variances that are changing from one observation to the next. The problem, though, with this method is that we don't know what sigma squared I is exactly. So we looked at a number of different ways that we could estimate it or deal with this unknown value to actually implement weighted least squares. How do we actually implement weighted least squares? Well, we, for example, use the LM function. If you remember, there's a weight argument in that actually does then the model estimation. We talked about robust regression. Well, why would someone want to use this? Well, maybe you have some influential observations. You don't have a good way to get around them. So what you do is you use a different estimation technique that comes about for using robust regression, where now your estimates are robust to these outliers or influential observations. We've looked at a number of ways to implement this robust regression as well. And lastly, we talked about non-parametric regression, in particular the Loess regression method. Make sure you know what it is, why someone would want to use it, how it actually works, the advantages and disadvantages of it compared to regular old regression models. Okay, so that's what I had to talk about regarding a test review. Are there any questions about the exam or any material? Are you just anxious for the semester to get over? Well, I talked a lot less than I had expected today. I guess we'll just call it a day. Thank you again for taking this course. I hope you feel as though that you got a lot out of it. Please feel free to come talk to me in the future if you want to take other STAT courses in our department that either I teach or maybe other people teach as well. So that's it for today. We'll see you for the final exam.